Johnson, and today I'm going to talk with you about the role of methodological quality in studies and meta-analyses. As a plan, I'm going to give you a guiding philosophy, a big picture of sorts in a few slides, and then I'll describe how methodological quality is commonly recorded for individual studies and under systematic reviews and meta-analysis. And then the primary part of the talk will be how meta-analysis should use methodological quality and what they do instead. I will discuss briefly methodological quality of meta-analyses. I've got a separate talk that already does that more. I'll give you a few main conclusions, and then I'll end with some discussion questions. So when I'm thinking about methodological quality, I think about the problem that scientists have and what I would call the art of divining the truth. We don't actually have any direct gauges of the truth. All we can do is divine it. We can deduce it. And that leads me to think about Zen and the Art of Motorcycle Maintenance, which, if you haven't read it, is a good read even today. I'm sure it won lots of awards back in the 1980s when it was released. And Persig, the author, explores the meaning and concept of quality, but in his words, he conceives it as undefinable. And that kind of defines what scientists have as a problem too, is how do you define it? So we're going to go that way, and we'll decide in the end if we know anything at all. But that's the crux of the matter. But I mean, if the data out there are not perfect, if they're flawed, then how is it possible we know anything at all? So, as by now if you've seen any of my my talks, you see I try to organize meta-analysis around 7 interrelated steps. And this is maybe the most interesting talk of the whole series, because methodological quality really is through this whole set of stuff that you've got going on here. A lot of people, it shows up even at the point of formulating, because if researchers decide, if a team of researchers doing a systematic review decides that they just want randomized controlled trials because those are the gold standard, they're already telling people we're going to exclude anything that isn't controlled. So quality can be a problem, can show up in the process even this early in the process. Obviously, methodological quality is going to be a coding feature, so it's step 3 as well. Probably not calculating. And then it should come up here in analyzing as well. That's what I'm going to argue today in this talk. And of course, when you're interpreting and disseminating, if you don't think about methodological quality, I think you're in trouble. Okay? So, guiding philosophy. Basically, when you've got higher quality research, it's more like this box on the left. The signal is popping out more than the background noise. When you've got lower quality research, signal-to-noise ratio it's hard to see the signal. So this is the basic principle that I use to think about methodological quality, is that these things that we're trying to use to gauge methodological quality should be helping us to isolate signal, maximize signal, and minimize noise. So in individual studies, we like to think about safeguards that people build into studies, and we like to think about how we're going to outweigh the threats to validity. So if there are too many threats to validity and we don't have enough safeguards, then obviously it's going to tilt this direction. If we can equalize them, maybe we can win this little battle. So validity is often, this is Cook and Campbell kind of thinking: internal validity, external validity, construct validity, statistical conclusion validity. And there are certain threats that we have, it's the wrong way, threats to those to the validity. Things like confounding of treatment versus control. If treatments are diffused from treatment to control, then it's going to weaken our ability to find a treatment effect. If there are demand characteristics, it might create a bigger effect size than you should be getting, stuff like that. History and maturation are surely important, and I'll come back to that as the talk goes along, because mostly when people are doing RCTs, they're trying to get rid of these effects, because if you do an RCT, the control arm, the treatment arm, all the arms in the RCT are having the very same history and maturation effects. You're equalizing these things. And if you don't have confounding, then you're maximizing internal validity, etc. So you have lots of study safeguards you can introduce. Random allocation to conditions is the hallmark of the RCT, of course. Blinding, so that they don't realize there's a treatment, maybe ideally. Blinding of personnel. Both participants in double-blind trials are considered, the better test of treatments, for example. And of course, we'd like to see unbiased outcome reporting. All of those things can go wrong. Okay. And then basically, I think the point can be made is that to the extent you've got these study safeguards, you're reducing bias, you're increasing quality, and it is a choice that investigators can make. They might not have resources for it, or there might be ethical qualms that stop them from doing it. Is it ethical not to give a treatment to controls, for example, when it's a dire condition that they face? All of these things come into the equation of study quality. So, Deeks et al. In 2003 found nearly 200 of them, so by now there must be more than 200 of them, and some focus on particular kinds of research. The two most comprehensive scales, and we've used some of these in our own work, are the Downs and Black and Newcastle-Ottawa scale. Something about Ottawa, they do a lot of these reporting standards and quality scales. So here, just some of the names of authors that have appeared with quality scales, starting with the A's and going through Bracken, or I guess is the highest in the alphabet. So these things have stuff in there that help people to assess whether studies tried to control internal validity in this example. I think this is from the Newcastle one. So did they try to blind subjects? Did they try to blind investigators? I mean, basically just spelling it out. So if the report has all this stuff in it, then they could get a higher score for internal validity. So as you go through coding these, you're looking at whether yes they did it, no they didn't, or maybe you're unable to determine. So the report quality might not be sufficient for you to judge. Cochrane collaboration has a risk of bias scale. These are the primary ones you tend to see in Cochrane reviews: selective reporting, incomplete outcome data, blinding of outcome assessment, blinding of participants and personnel, allocation concealment, and random sequence generation. So they code those for every individual study. And so you get a tally. You don't tally these, you think of them qualitatively different. Now, in Cochrane, you try to think, do these things create a risk of bias for the conclusions in question? So to the extent that these are negative and therefore red, is commonly colored red, versus green, which means, okay, that's good. So in this example, Cooper et al. Looks like the most dubious study. So if conclusions are resting on that study, then watch out. I mean, we probably have to do some follow-up work. Whereas if the conclusions are being borne out by these ones in green, then we would be less concerned that our conclusions from a systematic review or meta-analysis are prone to being biased in any way. Now notice these are exactly the same things over here that we saw on methodological quality scales. But, I think they're being a little cagey, I think, Cochrane, when they label it risk of bias. They don't want to say that it's necessarily quality. And I think it highlights the concern that I mentioned at the top, is the art of defining quality. So risk of bias or methodological quality, I consider them basically the same thing, just by another name. I think risk of bias is a nicer way to put it, because it's true that these things might or might not matter for the phenomenon in question and what effects you get. So I think we have to have a bit of humility about it, and I think Cochrane is wise that way, so maybe it's better not to call it methodological quality. So then maybe the other way to think of it is maybe it's in the eye of the beholder, and so something that's high quality to me is not high quality to you. Especially if it's an art, we should watch out for these things. Does methodological quality matter? So I had a colleague, a former student, remark, because she was doing a lot of meta-analyses at that point, that reviewers force us to add methodological quality scales, so we did it, but these scales never correlate with anything. And me, I'm thinking, well, should it matter? And mostly I thought, no, I don't think it should matter, or at least I couldn't develop clear predictions for it. With one big exception, because psychometric meta-analysis, the Schmidt and Hunter style approach to meta-analysis, do control factors that are known to shrink effect sizes toward the null value. Correlations of 0 or obscenities, differences of 0, odds ratios of 1, to the extent you've got unreliability, you just cannot find a larger effect. So you're going to be biased towards zero. Restriction of range does the same thing. There are many more sources of bias just like that. That's a whole nother talk. So we're going to kind of put that on the back burner for now and worry about everything else. You can go out and look. So here we're turning over to, well, what are experts recommending happen? And here I'm highlighting Jeff Valentine, who wrote a very fine chapter in the Handbook of Research Synthesis and Meta-Analysis a couple times now, and basically has reached the same conclusions in both. Should you rank the included studies by quality? Pretty much all of our sources are saying yes. Calculate averages of quality items within multiple discrete domains. So don't just do an overall average. Make it internal validity in one and external validity in another, that sort of thing. So it'd be okay to have averages on clumps of items rather than total scores. Essentially, the argument would be that items within a domain are scalable, but across domains are not. Okay? Weight them by quality, and no one says that. Use quality as a moderator. Card says maybe. Higgins and Green like this in the sense of subgroup analyses. And Valentine would say probably individual features of methodological quality could be used as sensitivity, but probably not total scores. And include studies of only higher quality. That's Higgins and Green saying yes, the others aren't really weighing in on that too explicitly. I'm going to argue against it as we go along here. So there's a form of meta-analysis called best evidence synthesis, also for systematic reviews, not necessarily just meta-analysis. Slavin introduced this in 1995 in the field of education, and the idea was to have an intelligent alternative to meta-analysis. I think that's a little judgmental. It's assuming that there are qualities that matter to the results, and I'm not sure that's the case. Maybe there's more noise because of things that people do. Essentially, what they do in a best evidence synthesis is to just use the best. This is like RCTs, for example, only. And maybe if you do a systematic review looking for RCTs, you might not find any in a subject. And, I've assigned the class one exactly like that. The Cochrane collaboration routinely advocates pooling results of RCTs and omitting studies with lower quality. And often I'll note in passing qualitative studies are also eliminated with prejudice, I could say. Caveats making, okay, so I've already mentioned this problem. There is reporting of study information and there's actual study information. So it's possible that a poorly conducted study can be exaggerated in print. People are lying about how well done it was. A high-quality study may have been poorly reported, so maybe it was published before Prisma standards appeared, for example, if it's a meta-analysis, and therefore they might have neglected to report some things that they should have reported. And the other thing is we shouldn't equate study size with high quality, because actually a high-quality study might be quite expensive, which might then in turn force the study to be smaller to live within its resources. And of course, for all of this, quality is going to be a primary limitation to any conclusions you reach. Okay, and we'll look more about that as we go along here. Now, pointing out the complications of reporting results, when you see industries involved in the trials and meta-analysis of their own products, you often see them skewing results in a direction that favors the product. So here's Turner et al.'s New England Journal of Medicine. Here's the journal version of antidepressant trials, where all but 3 of them are getting positive results. I mean, significantly favoring the antidepressant being evaluated in question. See, it's across this whole array of antidepressants. If you look at the FDA, the evidence is much more equivocal. The very same numbers you see on the left show up on the right, but now they're sorted on top, on the bottom more often. So what most people would consider the real data are much less impressive than were the ones that end up getting published. So beware what you read in the journals. In some places, publication pressures, p-hacking and the like, are going to create this kind of situation. Okay, what have meta-analysis been doing with quality? Are they more likely in more recent meta-analyses? How are they used? Are they using them qualitatively or quantitatively? And I was curious, along with my team, to see if they look at interactions with substantive moderators, and I'll explain. So here's Rob Lowe and Haley McDonald, my two former students. We wrote this paper together, and you can see the QR code here if you want to scan directly over to it. And so we're arguing, broadly speaking, that people should go panning for the gold in health research, that maybe we can learn something about methodological quality if we actually focus on it some. And then we also provide some recommendations for how to incorporate methodological quality in meta-analysis and models. So are they doing best evidence synthesis? Mostly, yes. Exercise and mental health. We looked at 3 different domains. Exercise and mental health is one of them. 85% of the time, exercise and blood pressure, 100% of those were. And HIV prevention, 69% of them were best evidence. Did they code methodological quality? Well, yes, mostly, but in some areas it's been slower. Exercise and mental health is the winner there. At least they've been on board faster, probably. HIV prevention, exercise, and blood pressure evenly split. Did they use methodological quality qualitatively? In exercise and mental health, yes. In the other places, it's more of a mix. HIV prevention, not. I found it very curious that often these teams would code methodological quality but not even consider it, and very basically in passing, they're giving it lip service. Did they use it in analyses? Very, very seldom with exercise and blood pressure, exercise and mental health, and HIV prevention. Did they model interactions? You're going to see it's only my team's doing this, and that's what made me interested in it. So exercise and mental health is where we've tried this first, but there's a sliver of them that have done it in HIV prevention too. Did they discuss methodological quality? Well, most of them were pretty good about that. But again, like I said, a lot of them aren't even discussing it, which is a shame. So most recent meta-analyses are more likely to follow the Cochrane handbook or to be registered as Cochrane meta-analyses, which does have a positive effect on quality. Recent meta-analyses are more likely to assess methodological qualities, use them qualitatively, and only a few have looked at the interactions. And many meta-analyses, as a caveat, I would point out the sample is too small to permit doing so. Now, these meta-analyses, I've been going on about this in most of my talks. You almost always have significant heterogeneity in meta-analyses. Here's a survey of mostly medical meta-analyses from 2003, Higgins et al. British Journal of Medicine, BMJ. And you can see there's the big tail over here that are 0 or less than 0. So it's fairly frequent that you see a lot of heterogeneity in meta-analysis, even in medical domains. The point would be that if you have higher and statistically significant values of I-squared, you're going to need moderators, which is again the reasons why Emily Hennessy and I have advocated very strongly topics plus M, adding moderators as a priori consideration of your meta-analysis. So here's another domain of research showing again that large heterogeneity is very, very likely. This was 29 different psychological bulletin articles that have 236 sub-meta-analyses. Only 14% of these were non-significant, and those were in meta-analyses that had lots of subgroups of meta-analyses. Mostly in psychological bulletin, you see articles that are published, and the interest in reviewing a subject in psychological bulletin would be, well, there's variety in the results. We need to figure out what's going on with them. So heterogeneity makes it more interesting, I would say. So we shouldn't really expect homogeneous results routinely, and indeed this is the case. So you got to come along and have moderators. And so this leads me to what we should be doing with meta-analyses that look at, you've got your ratings of methodological quality, what are you going to do with that? And so if signal to noise ratio is really the primary concern, then what we should see, the moderator factors are more likely to show up in high quality research. Okay, so I'm now moving it from just does a treatment work to when is it going to work better, because we've got heterogeneity, we should be worrying about moderators, and now we should be worrying about whether methodological quality deficits are undercutting our ability to find relationships or maybe worse, they're showing up in places like that, and it's only due to the incorporating lower quality research. So the question then becomes whether, like I just said, including studies with weaker results undermines the conclusions you've got. And I argue that's a moderator by quality interaction. We shouldn't just be putting methodological quality in as a main effect along with theoretical moderators. You should be asking whether the moderator effects go up or down depending on quality, and vice versa. Okay, so essentially we would advocate using individual or clusters of them that are very similar in interaction with theoretical moderators. So RCT versus non-RCT would be an example of that. Control versus uncontrolled would be a related other one. Blinding, whatever you want to do in these. And you could use some weighted scales of methodological quality, but you have to keep in mind the caveat that even a single methodological flaw might invalidate a study. So they get 94% of them, but that 6% is one item that happens to be blindness, and it just destroys the results, or whatever it is. I mean, the problem is we don't have a good theory for what that one is, but hang on. So we came up with several versions of patterns that would be interesting from a methodological quality times theoretical variable pattern. So this is version A. And so all of these graphs I'm going to show you, you've got the amount of a theoretical moderator. Imagine like it's dosage or something like that. If it's exercise trials, it might be dosage. In even psychosocial ones, it might be dosage of mindfulness training or whatever you're studying. So you'd expect a dose-response effect to occur. And in both of these graphs, we see them. Okay, so dose-response is kind of the classic moderator pattern that we would look for. And in this case, see what's happened? The confidence intervals, or the bands, around lower quality studies are wider than they are in the higher quality studies. Now, if you go and look at my moving constant technique video, you don't actually have to bifurcate the distribution of quality in half to do this analysis. You can use the moving constant technique to do this. But essentially what it would show is if you've got the same moderation happening and lower quality is higher, you're just going to have more noise over here than you will in the higher quality case where it's much more precise. So the signal-to-noise ratio is maximized in higher quality studies. Okay. And I've said all that. So here's an example of this. We did a meta-analysis of aerobic exercise and quality of life for cancer survivors. And for those that could manage 8 METs, metabolic equivalent of tasks, you saw a significant quality of life boost in longer term trials, but not brief trials. So it's telling you that don't expect an instant bolster in quality of life due to exercise. You need it to be a longer term trial. Now this trend only appeared in higher quality studies. And so the noise is all there on the other side, but it's present in the higher quality studies. So that's where you should see the signal-to-noise ratio maximized. So that's a lot like version B that I'm showing you right now, although there was some slope that was present in that last one. I didn't show it to you in the low-quality studies. In this example, you've got effects of interventions evident only in high quality studies. See how the confidence interval doesn't include the null effect? But over here in the low quality, the confidence interval all across the range. The treatment doesn't even have a noticeable impact, a detectable impact for lower quality studies. Whereas for higher quality studies, you see that dose response function appearing again. Okay? So, and just like the example I gave you, higher quality studies are more likely to detect intervention success. So here's an example of that, same kind of concept. This is aerobic exercise, and now it's reduction of depression for cancer survivors, and we've got 44 RCTs in this case. In the higher quality trials, you see reduction. Here's the dose response function. As you go up to 3 hours a week, you get a significant reduction, a large effect size almost showing up. But in lower quality trials, look, it's noise. There's not even a significant intervention effect going on there. All right, version C of this would be kind of the critic's dilemma. Maybe that's why I call this version C, is the critics. This is what the critics are worried about. Well, if you conclude those non-controlled trials, if you have the ones that aren't RCTs, you might get the effect there, but you're not going to find the dose response in the higher quality studies. So this is kind of the critic's worst nightmare. But the problem is, unless you do this analysis, you're not going to be able to show that this is the case. And in fact, in my review of the literature with Haley and Rob, we didn't find any examples of this. So it makes you wonder if people are being prejudiced towards lower quality studies. Okay. There's yet another pattern that might come out, and again, I don't have an exemplar to show you for this, but lower quality studies might routinely fail or almost fail to detect a treatment effect. Like there's no dose response effect in either of these graphs in this case. But look what happens. The higher quality studies, all the way across the dosage continuum, you still see a significant effect of the intervention. That does not include the null difference. Whereas lower quality ones, where you might sneak it out around the middle of that, where maybe the studies are more common in that range, but you won't find it anywhere else. Again, the idea would be showing literally that there's more noise for lower quality studies than higher quality studies. And as meta-analyses do this more and more, we might actually discover something reliable about methodological quality and might be able to generate some better theories about when it's important and when it's not. Okay, so I said all that. There are some challenges associated with this interactive approach to methodological quality. If you've got small literatures, you're just not going to be able to. If you loosen your selection criteria, and you allow the non-RCTs to enter in, you allow the uncontrolled studies to go in, it's going to increase the size of the literature, and then you can do these models, okay? It's more likely you could do them anyway. And then it's going to permit more knowledge to accrue about when methodological quality is important. Now, I would say as a general statement is that other, Cochrane reviews and other best synthesis reviews are generally too small for these analyses, so this is a problem. They make me wonder if maybe we're just tilting a windmill, so they know something we don't know. And I do have a caveat for this that I'll give you in a minute. So maybe like Don Quixote, who attacked windmills on his horse, maybe we're tilting at windmills and we worry about these quality dimensions. But again, like I say, because researchers aren't focusing on quality, they're not doing that heavy lift, we're just not learning enough about methodological quality to do a good job of it. Okay. Of course, if you have a homogeneous effects, you're not going to find any moderators. It's just impossible. And I would say that if you include lower quality studies, you're likely to get a lot more noise and more heterogeneity, and that's interesting. So now in our paper, we point out that no one has been showing how to fit simple slopes analyses and meta-analysis, but we did provide a technical summary in that paper that shows how to do it. And here's a shout out. There's a good methods paper in that. If someone wants to collaborate, I'm happy to. Now, methodological quality can help you a lot when you've got a large literature and it's got heterogeneous effects. So it could help you document whether the effect size depends on methodological quality. It could help you to evaluate, as I've just shown you, how trustworthy the moderator results effects are, and whether including lower quality designs harms you or not. And it can find out what methodological dimensions are most consequential to a particular phenomena. The approach is amenable to scales and individual artifacts. We argue that best evidence synthesis criteria should be loosened in order to empower these analyses and help shed light on, make a theory of methodological quality. And so we really wonder, is the Cochrane emphasis on best evidence merited? Okay. Other challenges. Well, there are staunch norms against lower quality designs. So in meta-analysis, you really the highest quality evidence, way over here on the right side of this graph, is meta-analysis of aggregated data, which is what I've just been showing you, or individual patient or participant data meta-analysis. So those are places that are arguing that you've got to rely on the quality distinctions back here all the way through the process. But we don't actually know that's the case because no one ever compares them. Do you see my point? All right, so I would say it's not that lower quality studies have no value at all. It's that they are more suspicious, okay? even higher, here's the point, even higher quality studies are imperfect. There's never been a perfect study, although it's a bit of a truism. Now, don't undermine theoretical moderators of effects. Why not use them and gain the extra statistical power? And I have a whole other talk about why including uncontrolled trials might be a good thing to do, might be your best friend in disguise. I mean, sometimes I argue in this talk the real action is in the repeated measure side of things, not the between groups comparison. So I argue you should go ahead and break the rules and include those uncontrolled trials. And maybe you can turn your worst enemy into your best friend. So in that talk, I mentioned these things, that if you include both RCTs and non-RCTs uncontrolled trials in the same meta-analysis, you get these kinds of results. So non-RCTs, you can imagine, maybe don't have control groups. Actually, there's probably a third category, another category. You could have uncontrolled. You could have quasi-experimental controls where there is a control group, but it's not randomized. Stuff like that. But to go with the idea, you've got a causal comparison from, if your meta-analysis is RCTs, go ahead and compare repeated measures of effects for treatment versus control. And you've got a way to examine whether RCTs and non-RCTs get different effects. In this example, maybe the non-RCTs get a bigger effect size than do the RCT designs on. It's kind of what I imagine. But again, no one's doing this work, so I don't know what kind of results you'd actually get. So including both means you're going to have more studies to model, probably greater variability in intervention features, so you're probably going to also get greater diversity in terms of population sampled, racially or other features. You're going to have more effectiveness information for more realistic circumstances. The non-RCTs done out in communities are effectiveness trials, and they're done with the support of communities, so they might well achieve larger effect sizes than we're getting typically in RCTs. So we could start solving some problems of the world if we started to look at these trials that aren't controlled. And then for clinicians, you're going to have a much better indication how much change should be expected from a treatment, even from RCTs. This is giving you, if you did the between subjects comparison, it's going to be maybe a medium effect size. But with looking at the repeated measures results, you're getting almost a large effect size, and the non-RCTs is much larger than RCTs. So if you include RCTs in the same review, then that permits you to rule out certain threats of validity, like history and maturation. Okay. Now, here's a caveat about including RCTs and non-RCTs in the same meta-analysis. This example I've got in front of you is from Lopez 2019. These are 172 arms, the results from 172 arms in RCTs focused on cognitive behavioral therapy for depression. And negative values imply improvement. So this is actually a great success story over here when this treatment group got that big of an effect. Next to it is a control group that got nearly as large of an effect. This is huge heterogeneity. Okay. So here's the problem, is that repeated measures outcomes are subject to everything possible. Everything out there that could cause change can cause change. So history, maturation, all the other stuff. And this is why people like the between subjects effects. They're going to neaten things up because control arms and treatment arms in their environments are experiencing the same pressures. So it's very likely that when you look at within subjects effects, repeated measures effects like we've got here, it's extremely likely that you're going to have more heterogeneity than between groups comparisons. And therefore, I would argue when you're thinking about your topics plus M, think hard about spatiotemporal factors, not just study and effect size level information as moderators and controls. So you might want to know whether groups are whether the target population is stigmatized, for example, and live in an area with extreme stigma versus less stigma. Things like that, that might interfere with cognitive behavioral therapy for depression or whatever your intervention is. In this image, it's kind of comforting to see that trials are so routinely seeing significant improvement of depression. Okay, but 0 would imply 0. This is one of the most extreme contour-enhanced funnel plots I've ever seen or made, for that matter, on my side. And Lopez et al. Did not put this graph in. I downloaded their data and I made this graph myself. And so I colored the control arms in red just to show, well, okay, they're also very heterogeneous, and treatment arms are even more so. And so a little bit of comforting that control arms are staying in a certain region, and it tends to be only treatments that are getting the really large effects. But now if you're emphasizing the between groups effect, again, you're going to be saying, well, there's like a half a standard deviation difference between treatments and controls on average. Look at all this improvement. This is wonderful news for the world. This is great mental health resulting, well, better mental health anyway. And that would take us into a more theoretical discussion about what should be controlled in the trials, but you get the idea. There's so many things that could be happening on the ground where these trials are taking place that could cause or facilitate or inhibit changes in the intervention itself. Okay. So, more conclusions from this. Look, I'm arguing methodological quality pervades our thinking, but we don't actually know what it is, okay? There's very little systematic evidence about what actually matters. So we should get off our high horse and be more open-minded about it. So if you, I've already argued this, if you exclude presumably lower quality studies, you're really being prejudiced against those studies, and you don't actually know that they're going to produce different results. Okay, it's a form of best evidence synthesis, but it appears prejudiced against so-called low-quality trials. So maybe uncontrolled trials is where the gold is, and so why not learn from them and break the rules? All right, so briefly, methodological quality of meta-analyses. So the AmStar tool is a very popular choice, and this is an instrument that built on empirical data collected with previously done tools and utilizing expert opinion. This is Shea et al., the original authors. They condensed 37 items down to 11, and this has been widely used. They consider it reliable and valid, and most people are agreeing that it has at least a modicum of it. I mean, although it developed in a more medical context, maybe sometimes there are things that are missing. They've subsequently expanded it to 16 items, but they've retained basically the same critical items from the original. Did they register before they commence? So here's my chance again to tout topics plus M. Make sure that those M's are getting spelled out. Do you have an adequate literature search? Does the review justify excluding individual studies? Do they consider risk of bias? So here's us being meta again. If you're going to do a good systematic review, you must consider the risk of bias. In terms of the conclusions. Appropriateness of methodological methods, so this means the stats. Did you consider, again, risk of bias shows up twice in interpreting the results of the review. If you use the AmStar instrument or anyone like this, you could actually gauge trends across the literature. Here we have a total score on the AmStar version of it that we created that was a little more specific about the domain in question, which is exercise for blood pressure reductions. Here you see the history of a review of a literature area. I think there are 32 meta-analyses that are coded in this graph, and you can see back in the 90s they really weren't very good, but they've steadily gotten better over time. And in part that's because we've had different standards appearing over time. Quorum in 1996, Moose in 2000, Prisma in 2009, and I guess we could add another one because we've got an updated Prisma around here. Seeing with something like this is that over time the conclusions of these papers are getting more and more reliable. We're getting a better indication when exercise can improve blood pressure. Our own meta-analyses, I suppose, would be scattered in here, and we've managed to get all the AmStars done, and indeed we start to see dose-response functions, whereas none of these papers, these meta-analyses that were published beforehand, have shown dose-response functions. They did show significant effects of exercise reducing blood pressure, but they weren't literally showing dose-response functions. So we've managed to get rid of the noise and find the signal in the trials, and we think that's because we use higher quality methods. Prisma is out there, and it's a reporting standard, emphasis on reporting. It's gone through 2 versions. Still has 27 items. It ensures enough information to evaluate the quality. It's not a quality standard itself. It often implies standards, but essentially it's not grading reports to say that I did something, that I followed Prisma. We make this point in a 2019 paper, Emily Hennessy and I. Following Prisma reporting standards does not guarantee quality methods because the reporting standards are meant to enable a reader to judge quality. Without reporting it, we can't tell if you did it well or not. So in other words, you could report all the Prisma standards yet still be worthless as a review. I mean, perhaps it addressed the wrong question or something else. And then people have gone out and checked whether people in their reviews who say that they claim conformity to Prisma, and 97% of them are not completely, though there's evidence that having the Prisma standard still helps. So in Emily's and my paper, we put the M-star items together with the Prisma items. We excluded all the ones that were purely stylistic, like having a structured abstract or something like that, which Prisma recommends. And what you see when you compare them side by side is that the M-star is much more stringent, much more careful in terms of defining quality. So it requires you to be more specific about what it means to have a high quality review. Of course, we advance that we should go even farther, so there's our topics plus M mention again. Now, in the end, okay, if all the data are flawed, how is it possible we know anything at all? And talking about methodological quality maybe is even more serious than a lot of other subjects. But there are 7 main conclusions I would advocate. Methodological quality matters. When you have better methods, it does create a better chance for reliable conclusions. So that whole signal to noise ratio thing is here, and I think this is the grand truth of methodological quality. Problem is we don't really know when methodological quality matters. I mean, psychometrics is the only area with clear predictions. You know, Valentine's writing, he argues that, well, perhaps quality could be determined within particular domains, like exercise science or something like that, versus another whole set in social psychology or what have you. And he might well be right, but unless we focus on this, we're not going to get it. It's a truism, but there's never been a perfect study. How can you argue that? Anything that looks perfect probably has something that went wrong. But of course, a lot of studies have scored 100% on methodological quality scale, so they look perfect. Total scores may often be misguided because even one flaw can invalidate a study, so beware of the use of total scores. We argue in this paper that variations in methodological quality allow you to do sensitivity tests for robustness of your moderator effects, especially, but all effects. Methodological quality is relevant no matter the type of meta-analysis, and I would say even any systematic review, whether it's a meta-synthesis with qualitative work or a systematic review qualitatively reviewing results, you should still think about methodological quality. We know stuff, but not enough. So I'll leave you with a few discussion questions. How do you define quality? Should systematic reviews routinely eliminate all uncontrolled studies from their samples? I mean, all non-RCTs, all quasi-experimental, and just have RCTs? Should systematic reviews routinely eliminate qualitative studies from their samples, and vice versa, as though they're not reviewing the same literature? In meta-analysis, how should we best model methodological quality of the included studies? Those are important questions that I leave you with. Have a great day.